Welcome to our review chapter 0, lesson number 2, real numbers. So we're going to start off with some vocabulary, and you can see that I already wrote in here, so I'm going to erase that. We have natural numbers, whole numbers, integers, and rational numbers. So your natural numbers are 1, 2, 3, 4, 5, and continuing on forever. Your natural numbers are the pickiest ones. So that starts off in the middle. And your whole numbers are all of your natural numbers plus 0. So 0, 1, 2, 3, 4. So your whole numbers are added in there. If you have a number that's a natural number, it is also a whole number. But not all whole numbers are natural numbers. Because, right, 0 is only a whole number. It's not a natural number. Now we're going to add on integers. So integers are all of your whole numbers, and now we're adding in negative numbers. So -3, -2, -1, 0, 1, 2, 3, 4, going up to infinity and going all the way down to infinity. So if you have a natural number, it's also a whole number and an integer. A whole number is always an integer. But an integer is not always a whole number because of the positive numbers. And then you have rational numbers. So what rational numbers are numbers that can be expressed as a fraction or a terminating or repeating decimal. So 1.2, 0.3 repeating. So if there's a pattern that you can recognize in your decimal, or if it's a fraction. Okay, so pi, like up on the wall, that is not a rational number because it doesn't repeat and it's never ending. So if you have a rational number, that doesn't mean it's an integer, but an integer is always a rational number. So when you look at this chart, I'm going to use a different color here to help us recognize. If I have a whole number, everything that's outside is included. Okay, integers and rational numbers are always together, but rational numbers aren't always integers. If you have a natural number, it's also a whole number, an integer, and a rational number. And be sure to raise your hand and ask me if you're confused about that, and I will try to explain it in other terms. Now we got some more vocab here for us. We've got a square root. And what a square root is it's one of two equal factors of a number. So for example, the square root of 25 is 5. Because 5 times 5, both those numbers are the same, equals 25. A principal square root is the non-negative square root of a number. So that would be 5. Because also, -5 times -5 equals 25. So there's two different numbers that could be that square root there, but what you usually pick your principal square root, which is that positive number. A perfect square is a number with a square root that is a rational number. Okay, so the square root of 25 is a perfect square. The square root of 36 is a perfect square because that is 6. The square root of 49 is a perfect square because that is 7. Making sense? Then irrational numbers are decimals that do not terminate or repeat. So like pi. Or if you type in some crazy thing like I'm trying to think, the square root of 3 is like 1.73205 continuing on forever. It doesn't have a pattern. It's irrational. So your irrational numbers are over here in their own land if we were to create or continue our chart from the other page. And then rational and irrational numbers all fall under the category of real numbers. So what we're going to do here is we are going to classify our real numbers. So we're going to name the set or sets of numbers to which each real number belongs. So 5 20-seconds. That's written as a fraction. It said here rational numbers can be expressed as a fraction. Is it an integer too? Nope. So that one is just a rational number. The square root of 81. I know that equals 9. And 9 is a natural number, right? 1, 2, 3, 4, 5, continuing on. If a number is a natural number, that means it's also a whole number, it's also an integer, and it's also a rational number. It fits into all of those categories. And then the square root of 56 comes out to be, when I punch it into my calculator, something like 7.48334, continuing on forever. Is there a pattern in that? Is it repeating anything? No. So that would be an irrational number. Some more vocabulary. What a graph is it's a set of numbers that you can draw or plot the points named by those numbers on a number line. I don't like how I defined that. So when you graph, you draw or plot the points named by numbers on a number line. That makes more sense. So graphing is where you're putting whatever the point is on a number line. So like here, if I wanted to graph, we got 0, 1, 2, 3, 4. If I want to graph the number 2, I'm going to put a point on there. Boom, I just graphed the number 2. This dot right here, where I graphed it, is the coordinate. So 2 is your coordinate because that's the number that corresponds with that point. Now, if we want to graph and order real numbers, we're going to have to first figure out what I should increase by here. We've got 5/3, -4/3, 2/3, and -1/3. So I've got both negative numbers and positive numbers, so I'm going to start off with 0. And because everything's in thirds, I'm going to be going up by thirds. So 1/3, 2/3, 3/3, which is 1. 1 1/3 then, which is also the same thing as 4/3. And then we'll go backwards the same. So we'll have -1/3, -2/3, -1, -1 1/3, which is -4/3, continuing on. So here I need to graph 5/3. Well, 4/3 is here. I obviously didn't make enough room. Here's our 5/3. Plotted. I graphed it. -4/3. Here we go. Got it. I'm just crossing it off so I know I put my things down. 2/3. 1/3. 2/3. Boom. And the negatives, so we're going to the left. -1/3. Boom. I graphed all of my points. Sometimes it's going to give it to us in crazy ways. So I'm going to try to get everything into a similar type of format. So 6 4/5, let's get everything into decimals. So 4/5 is the same thing as 8/10, so that's 6.8. So I changed that one. The square root of 49, good thing I know that's 7 because 7 times 7 equals 49. 6.3 repeating is there. And then the square root of 57, and we talked about that one earlier for whatever reason. No, we didn't. The square root of 57. I'm having a hard time remembering this off the top of my head, so I'm getting out my calculator and going. The square root of 57 is 7.4, or not 4, 5, 4, 9, 8, 3, continuing on randomly forever. So it's an irrational number. So now I need to kind of graph these, and I'm not going to be able to be very perfect with this one, but we know our numbers need to range from 6 to 7. So 6 is going to be at our bottom here. We're going to get to 7 here. And then we have numbers that are bigger than 7, so we'll have 8. So 7, that's an easy one to graph. 6.8, is that going to be closer to 6 or 7? Well, that's closer to 7, so it's somewhere in here. Graphed. 6.3 repeating, it's closer to our 6, so it's somewhere in there. And then 7.54983, that is somewhere in here. And if you are graphing these, you should label them. I'm sorry that I didn't. So we've got 6.3 repeating. Our 6.8 was actually 6 4/5. 7 is the square root of 49. And then the square root of 57. Now we're moving on totally away from graphing, and we need to simplify our square roots. So we've got the square root of 4 over 121. So what we're going to do to figure that out is I can go, 4 and 121. Those are perfect squares. So I can look at this like, what times what equals 4? 2 times 2 equals 4. And what times what equals 121? The square root of 121 is 11. So if I were to take that number and square it, so I just found the principal square root of both our numerator and our denominator. And then if I were to square that, which you do to the top, you do to the bottom, we would end up with 4 over 121. So you're just finding the square root of those two numbers, and then that still would be squared. Because the square root and squared are opposites, just like plus and minus and times and divide, they cancel each other out. So they both cancel out. And so the square root of 4 over 121 is 2/11. So then over here, we're going to continue with the same thing. The square root of 49 is 7. The square root of 256 is 16. So if you were to square that, you would get the answer that's in our original question. Then we still have negative and the square root sign. Squared and square root cancel each other out. So we still have 7/16 and then the negative symbol. So our answer there is negative 7/16. And then finally, estimating. So you estimate each square root to the nearest whole number. So the first thing I like to do is kind of write down our perfect squares. So we have 1, 2, 3, 4, 5, 6. Just to start off with. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. When you're estimating square roots, what you do is you take this number, pick which perfect square it's closest to, or you find which squares it's in between. So it's somewhere in between the square root of 9 and the square root of 16, because 15 lands in between 9 and 16. So the square root of 15 lands somewhere in between 3 and 4. Since 15 is closer than 16 than it is to 9, our best whole number estimate for the square root of 15 would be 4. Okay, and then 130 over here. For some reason, I always remember that the square root of 11 is 121. That's just something that has always stuck in my head. Or that 11 squared is 121. So then I'm going to go, okay, let's figure out some numbers around that, because 130 is pretty close to 121. So I'm going to go 12 squared equals 144. So our square root of 130 is somewhere in between 11 and 12. Is 130 closer to 121 or 124? It's closer to 121. So the square root of 130's closest whole number estimate is 11. And if you're having any questions on these, I can come over and do some more examples with you. So just be sure to ask.